Today we are going to discuss about a finite state machine model. The state machine model is used for modeling reactive or even driven embedded system whose processing behavior are dependent on state transients. Embedded system used in control and industrial applications are typical examples for event driven system. The state machine model describes the system behavior with states, events, actions, and transients. State is a representation of current situation. An event is an input to the state. Transient is a movement from one state to other. And action is activity to be performed by the state machine. Let's see an importance of FSM model with an example. Let us consider the design of an embedded system for driver or passenger seatbelt warning system in an automotive using the FSM model. The system requirements are captured as one, when the vehicle ignition is turned on and the seatbelt is not fastened within 10 seconds of ignition on, the system generates an alarm signal for 5 seconds. Second, the alarm is turned off when the alarm time 5 seconds expires or if the driver or passenger fastens the belt or if the ignition switch is turned off, whichever happens first. So this is the FSM model for automatic seatbelt warning system. In this example, it has three states: alarm off, waiting, alarm on. When the event ignition key is on, the state is changed from alarm off to waiting. So waiting time here, the waiting state has is a two events. One is the ignition key off or seatbelt on. Another one is timer expired. If ignition key off or seatbelt on the event occurs, the waiting state is goes or returns to the initial state alarm off. Otherwise, if the timer expires, then it is the state is changed from waiting state to alarm on state. Alarm on state is it is continuously running until the seatbelt on or the ignition key off. If the seatbelt on or ignition key off, this event occurs or alarm timer expires. It is a 5 seconds off. Then the state is changed from alarm on to off state. We can develop a FSM model for timer. The timer has three states: ideal states, ready states, running state. Ideal means the normal condition, the timer is not running. When the event load timer specified count is loaded in timer, the counter is said to be ready state. When the counter is in ready state, if the event occurs, that is start timer, start signal is applied to timer, then timer is running. Timer is running till the event occurs, that is a stop timer or timer expires, then the running state to ideal state. So using the FSM model, system behavior can be analyzed. So I already mentioned that the state machine model is used for modeling reactive or event driven system. Let's see another example. FSM model for tea coffee vending machine. Design, the example is design an automatic tea coffee vending machine based on FSM model for the following requirements. The tea coffee vending machine is initiated by user inserting a 5 rupee coin. After inserting the coin, the user can either select copy or T or press cancel to cancel the order and take back the coin. So what is the FSM model? The FSM model for tea coffee vending machine has four states: state A, state B, state C, and state D. State A, wait for coin. State B, wait for user input. State C, dispense tea. And state D, dispense coffee. Let's see the system behavior start from state A. When the event insert coin occurs, the state A is changed to state B. In this state, two events may occur. One is after inserting the coin, the user can either select coffee or tea or press cancel to cancel the order. If the event cancel the order, state B is returns to state A. Otherwise, the other events are press T button. This is the event. The state B is changed to state C. If the event coffee button press occurs, the state B is changed to state D. At state C, the event D dispense occurs, it returns to the insert state. Similarly for state D, when the coffee dispense, it goes to the insert state. So this is the FSM model for tea coffee vending machines. Thank you.